Well, looks like we can start. Welcome back, everyone. So now we're going to do our second exam review, the one for exam two. Our exam two is going to be next Monday, like we discussed, over these specific units. And same strategies that we discussed are still relevant to studying for this exam, same for exam three and the final exam and so on. Definitely what I would recommend doing first is getting your page of notes put together. It'll be just like before, 8.5 by 11 inch both sides, and it can be printed out or handwritten. I have a formula sheet that is attached with some bigger formulas, the ones that we're using in finance. So be sure to double check that sheet as well. So you won't have to double put down the same formula that's already provided on the last exam. Once you have your page of notes put together, next thing I'd recommend doing is just getting fully caught up on the quizzes. Particularly quiz number 7, which is due today, is on unit 4D, and that'll be pretty helpful to go through that one. The prior quiz, I believe, is on unit 4B and so on. So if you're caught up on all those quizzes, next best stop is to get caught up on the homework in MyLab. And it does do double duty. It's worth a good amount of the class grade. It also will help you prepare for exam two at the same time. The questions are going to be similar. Then after that, once you're fully caught up on both ends of the work, the quizzes and the MyLab homework through here, then it's a good time to turn to either versions of these exams. Version 1, the problems that we have done before, I've omitted some of them, the ones that just didn't look like they'd fit for a good exam question. And version 2 is just new, fresh problems based on the ones from here. Well, already in the chat, I have a suggestion to take a look into problem number 4. And I believe you're possibly referring to version 2 when you mentioned that. But other questions or comments, folks, before we start out? Okay, for this exam review that we're doing, everything that we do is going to be put on a document, this one right here, then saved as a PDF, just like any other work we did. And I'll post the results probably somewhere right here, since we did it this week. And now going back to Amy's suggestion, it looks like we're looking into this sample exam version 2 potentially. Let me know if you're, well, probably not this one, since this one starts off on problem number 8, where the last exam picked up. Let me open up this one here. Here's the version 1. So these are the problems that were from the lecture notes. Version 2 are brand new problems. And I'll leave it open to the class. This review will be fairly student directed. Are there any questions or problems that folks would like to take a look at first? They could be from any version of the sample exams or from any other problem that you might have saw in MyLab. I'm not opposed to taking a look into a quiz problem either. So I'll turn it over to the class. Any suggestions on where you'd all would like to start? Well, one thing we can do is, I think the sample exam problems 2, version 2, is a good set of notes because these are fresh, brand new problems. And what we could do is just go on a unit by unit basis, pick out one or two, and work our way through the notes. And the moment I get some suggestions, thanks for throwing one out there, Trinity, we'll definitely prioritize the student suggestions. So let's take a look at problem number 42 of exam 2. So 42 going down to compounding. I'm glad you suggested this one. This is a great one to practice, and it definitely goes along with one comment I should have made as well that I just neglected to do so. Don't forget that on this exam, the calculator is not just a suggestion, it's a requirement. It's particularly for these problems here. The Math Center does have a couple spares, but that's one variable you don't want to change over. It's good to be using the same exact calculator every single time so that you don't have to get used to a brand new loaner calculator when you're in the exam room. And it's very feasible that they could just run out of calculators as well. So to help out with this problem, let's imagine we're doing it in a real exam setting. You might have the formulas that are relevant when you bring your page of notes, but you might just turn back to the last page because, like we mentioned, the financial formulas and looks like stuff about absolute and relative error are provided. This problem that Trinity suggests is a compound interest problem, so let's throw this into the notes. We'll imagine we're studying this problem from the point of view of flipping back to this page here to see how it goes, and then solving the problem. Let me just fix one thing. Okay, so this problem starts off by saying, suppose you invest a $4,000 graduation gift, that's quite generous, possibly a grandparent, into a mutual fund to start building a long-term retirement nest egg. So that's very forward-thinking. The fund is expected to earn an average APR 6% compounded annually, and we'll use a compound interest formula to determine what the accumulated balance will be after 15 years. So first thing we want to do is, this is kind of like a statistics problem, we dissect the context. We want to determine what the principal amount is, the initial investment. That's going to be the entire $4,000 graduation gift. We also need to determine what is the interest rate, the annual percentage rate. And that's this portion right here, 6%. Written as a decimal, so 0.06. Now, we need to know how many compoundings there are going to be. When it said compounded annually, this implies that the n that we see in the formula is 1, and is the number of compoundings per year. So if it says annually, it's a 1, and the formula just simplifies. We're going to just imagine 1 isn't even there. So that's a nicer version of this formula. We want to find the balance after 15 years. So the 15 years here is the term of the loan, or rather the investment. So y equals 15 years. So for these kind of problems, the exam 2 isn't going to be very long. It's going to be about 10 questions altogether. Not every question is going to have multiple parts. This type of question would be one whole question. And if we're imagining this as a 5-point problem, just saying what these values are down on paper, that would be worth 1 point. Putting it into the formula correctly is going to be worth the next 3 points. And then the final point is just doing the computation. So we want to find the accumulated balance. They're talking about the amount after 15 years. So this right here is the major insurance on just the partial credit for the exam. Put amount equals 4,000 for principal. So plugging in that spot. I'll write it like this instead of the implicit times. We'll just say it implicitly like this. 1 plus the APR, 0.06. So that fills in that position. Raise this to power 15. So that's going to be the y variable there. And now it's just a practice with using our calculator. We spent a good amount of time going through this, but this is a skill to definitely brush up on before the exam. If you have your calculator available with you right now, then give this a try and let me know if you're getting different values. We'll take another look at it to make sure that we get through what will be, say, the last point on the exam. So take 4,000, 1 plus 0.06, raise it to the exponent of 15. And for these kind of problems, if it's money, it's implied that we'll round this to the nearest cent. So after 15 years, $9,586.23. Let me double check that. Okay. Well, we got it, folks. Took a while to get there, 15 years, but now it's more than double the original principal. Any questions on getting through that number 42? Okay. Well, while we're there, let's take a look into another problem. And again, open to suggestions at any time in the chat. Even if there's a lot of suggestions, I'll put them down on paper We'll get to them on a first come, first served basis for whichever questions you would all like to take a look into. So, but while we're here, while we're on this topic, this was a compounded annually problem. Let's say we change this over to something that's going to be compounded maybe monthly on this one, or this one says also compounded monthly, it turns out on this one. Looks like they're both pretty similar problems. This one has a little bit more context. Let's try out 44. Sometimes the challenge is rolling through the context, getting all the information we need. So let's put this down on review and try it out again. Well, we could cite that formula as we need. Let's maybe scroll down to this point. So for a pretty similar scenario, it says, suppose you resigned from a job that you've been working at for 12 years. Hopefully this was an amicable resignation. Didn't say you were terminated, so this sounds like this was a personal choice. You worked for a company for 12 years is the assumption. And over the course of time with the company, your IRA, your individual retirement account that you might have had, maybe there's employee matching there, it grew to the value of $43,571.22. And you have the option of cashing this out. There's usually very severe penalties on doing so. But instead of cashing it out, you decide to roll it over into a personal IRA that earns an average APR of 7.35% compounded monthly, pretty typical for an IRA. We want to know what will the value be on this account in 40 years. So we resigned for a position that we held for a while. That's not enough to really retire on, but this happened earlier enough in our life that we let the account sit for 40 years. We want to know what its value is going to be. It might not be our primary form of retirement, but we'll see just how good this is going to do for us. First thing we need to do is determine what all the quantities are. And we have to be really careful with the context on this one. Sometimes these can be pretty tricky. For example, when it says 12 years here, well, that's not the term of the investment. That was just how long you were working with the company. So we need to skip over that value. This value right here of $43,571, that's going to be the initial investment or the principal, like in the last problem. So we're going to start there. Principal is substantial, 43,571, 22 cents. Every cent matters with this. It's going to be put into a personal IRA. And here's where we really don't know exactly what the value is in 40 years. Because here's where we're making a pretty big assumption. We're assuming that that average APR stays exactly where it is. So pretty big assumption there, but we'll go with it for the sake of the problem. Assume the average percent return on this is going to be 7.35%. So that's the interest rate on the account. And we're hoping that that stays constant for 40 years. The next thing, this one's told we're compounding monthly. So the end value does matter. That 12 is going to go in the denominator here. That's going to multiply the term length here. This time we have 40 years we're considering altogether. So we'll say y is 40 years. So that's all the values picked out through the context. And we're pretty much looking at the right formula here. We just have to make a couple adjustments. Divide by 12 here, multiply by 12 here with all the new values like we mentioned. Let's put this down below just so we can see this as it goes. As we work through it. So we'll say next, the amount in 40 years is going to be the starting principal, 43,571, 22 cents, multiplying the group, 1 plus APR. Here we need to be cautious, change this over to a decimal, 0.0735. Divide that by 12, coming from the number of compoundings per year, and raise this to an exponent of 12 times 40. So this one is now a lot more challenging to get into the calculator just right. Let me know if you're getting any different values, and we'll look at this one more closely, the calculator side of it. In this calculator, here's what we're going to get. 43,571.22 cents. 1 plus 0.07, 1 plus 0.0735 twelfths. Raised to the power of 12 times 40 gives us close to $1 million. So it's a sizable chunk. But keep it in mind also, this is in 40 years, and inflation just keeps on going in 40 years. Close to $1 million might not be that much money in 40 years. So if we really wanted this to come out to a nice value, probably more accounts are needed, more contributions into this personal account are needed. So we can never get too excited about some computation like this 40 years down the line, unless we are also thinking about inflation at the same exact time. But nonetheless, here's how much will be in the account. Also assuming that average APR doesn't fluctuate, and it probably will for a mutual fund. But we've got 816,828. And the cents are important as well. 93 cents. So that's two different versions of the same kind of problem. One for compounding annually, so one time per year. Another one with trickier contexts, and so a trickier formula, compounding 12 times a year or monthly. Yeah, absolutely. Let's go next to example 31A of sample exam 2. Any last questions or thoughts, folks, on problem 44 before we jump gears to the next one?
I guess I did have one question. Where the variable is, I mean, the exponent after the where the exponents go, in what situation are they negative and positive?
Oh, that's a great question. So whenever we're looking at the amount in an account after a number of years, it's always going to be positive in these cases, like we see both here and here. But if we're changing over and saying, maybe this is an amount that we're trying to pay off, and we're looking into how many payments or how big are the payments going to be if we're trying to pay this off in, say, 40 years or something along those lines. In that case, we would use this formula here. Slightly more convoluted, a little bit more to put together, and that's the one and only time you'll get a negative exponent right in that spot. Does that make sense with that question there?
Yeah. When I was on quiz 7, um, the bottom answer, the bottom from doing the bottom equation into getting the answer. Sorry. Oh my gosh. I got a negative answer, but then I just figured that's where the negative went is on the exponent. So thank you.
Yep, absolutely. So we'll make sure to do one of these problems as well, because again, they're extra tricky, I'd say, on getting it into the calculator. But first, let's make sure we jump to the questions coming through. So far, I've got two great suggestions. Example 31A, and next we'll be doing 45 of sample exam 2 afterwards. So let's take a look into this one. Forgot the problem already. 31 part A. Okay, so this one says for the following pair of measurements, state which one is more accurate, which one is more precise. I remember these ones being pretty tricky when we took a look into them. So this is a great suggestion for a next problem. First thing we should do is let's state our definitions. And if it's kind of foggy, then this is a good indication that this is probably a good set of definitions to put on your page of notes. So when it comes to precision, to me, this one's the easier one to think about. This is how many places, let's say how many decimal places is the measurement. So if we're measuring heights, and we have one measurement system that's to the nearest eighth of an inch, but a whole another measurement system that's to the nearest 0.01 inches, that would be to a smaller decimal place, and that would be the more precise measurement. But accuracy here, accuracy is talking about something differently. This is really how close a measurement is to a true value. And I think I recall that when we did these in the lecture notes, we followed the definition to the letter, and we thought of accuracy as having the smallest relative error. But if you look into absolute error and solve it that way, you would get the same exact answer. So I would say either way you decide to go would be appropriate. Either compute the absolute error or the relative error. Okay, so with those two ideas down on paper for what the accuracy is versus precision, here's the scenario. Well, true value is important here, so let's highlight that as we go. It says a student runs a campus charity 5K race, which has an official certified course length of exactly 3.10 miles. We'll think of that as being the true actual length of this race. And it says next, their older smartwatch, which records distance to the nearest 0.001 miles, lost its GPS signal briefly and recorded a total distance of 2.65 miles. Meanwhile, their friend's basic step counter app, which only logs distance to the nearest half mile, increments, recorded that there was a run of 3 miles on this race. There's two different quantities that we're looking into. We want to know which one's more accurate, which one's more precise, the basic step counter app versus the older smartwatch. So this kind of splits into two. Let's consider the smartwatch, which has that precision, recorded that total distance. So let's start with that one. Smart watch. Let's begin with maybe the precision. It records distance to the nearest 0.01 miles, so we can say the precision is going to be the nearest 0.01 or nearest hundredth of a mile. So we have a precision there, and it lost its signal, so it gave a measurement of how much through the race was done of 2.65 miles, measured 2.65 miles. Then the other side of the problem is the basic step counter app has a different amount of precision and a different measurement that it made. So we'll say here, step counter application, or app for short, its precision is to the nearest 0.5 miles or a half a mile. So already we kind of have half the question, right? It wants to know which one is more precise. And this one is the more precise measurement because it's to the nearest 0.01 miles. It's talking about the decimal places that it's able to approximate values to. So let's say here, the most precise is the smartwatch. It doesn't mean it's the most accurate, although it could. It just depends on how the problem is put together, what's going on in this context. So now to determine which one's more accurate, we're looking into how close they are to the true value, which means when you do this as an exam question, you can look into either the absolute error, measured value minus the true value, or we can look into it in terms of the relative error. Because both versions answer the question, I'm not going to be too worried which one you go for. We did this every time in the notes. We computed the relative error. So let's say here, absolute error is going to be the measured value. It was measured at 2.65 miles minus the true value. The true value of the race is 3.10 miles. And someone else measured this, but we're hoping that that is a highly, highly accurate value. Its true value is intended to be exactly 3.10 miles. And so the absolute error on this one, let's consult a calculator. It'll come out as 2.65 minus 3.10. So it's negative 0.45 miles. It's off by almost a half a mile short. Now for the step counter app, let's look at the absolute error on this one as well. On this app, let's see, I forgot to write down what it measured. See if I can just fit that in. It measured 3.0 miles. It's a basic application and it's just counting steps, which is assuming a stride length. So it's not meant to be very accurate in the first place. However, when we look into this, if it measured 3 miles, absolute error is going to be the measured value, 3 miles, minus the true value, 3.10 miles. And this one will come out as a negative 0.10 miles. And this might not be a bad one just to throw onto the notes. We're thinking in terms of absolute error when we did those two computations. Let's put that down below. So we found both absolute errors. And once again, absolute error is sufficient to determine which one's more accurate. It's going to be the one that's closer to 0. This one is off by nearly half a mile. This one's off by just a tenth of a mile. So right here, we can make a conclusion that the most precise one is the smartwatch, but it's precisely more wrong at nearly a half a miles. That most accurate is the step counter app. Even though it's somewhat of a crude measurement device, it didn't lose its GPS signal, so it just happened to win out today. It became the more accurate measurement. Well, that's the dichotomy of precision versus accuracy. That always is a kind of a tricky concept because they sound like the same exact statements. So these kind of concepts, or going back to the definitions in that unit, would be great additions to the notes. And again, we resolved the problem just on terms of absolute error. Relative error would have been fine as well, but if you're doing this as an exam question, I think that's an okay step to stop at. I'll leave it up to the class though. Should we go to absolute error or any other questions on this one whatsoever? Or, excuse me, go to relative error. Okay, so going in terms of absolute error, these are the conclusions we would make on this one. Next problem we're going to take a look into is problem 45. That sounds like it's probably the one on payments, so that's a good one to do for sure. Loan payment and credit card payments and mortgages. And let's go for all parts of 45. This one's kind of tricky to bring in as a screenshot. So we want to make sure we have space for each one of those parts. But here's our hack. We'll just do a couple screenshots. Okay, so new financial situation. It says married couple are looking to purchase their first home. The home is valued at that amount there. The loan will be a fixed APR, 5.49%, and the term is going to be 30 years on this one. So we're doing an analysis on the mortgage payment, total amount paid, and percent going to both the principal and to just pure interest. So same kind of problems like we did in class for this context. First thing we want to do is identify all the moving parts. The principal that we're trying to now pay down is going to be the 375,000 rather, 500. So 375, 500 has an APR of that percentage there. So APR will be 0.0549. The term of this loan is 30 years. But in all these problems, one comment we made is we're trying to make these somewhat realistic. So we made sure the number of payments per year is always 12 on every single one of them. Even though we stated the formula generically with a placeholder for n, we threw in n on each problem that we did in the class. The thing that does change is the term length on this one. 30 years means they're going to pay a lot of interest overall, and we'll do the analysis of just how much they're going to pay. Very first step we should take is we need to get that formula on paper to be accurate. So the formula goes, payment is going to be equal to the principal times APR. Then it's divided by n, but we're going to throw a 12 in there. Then down in the denominator, we have a grouping symbol here just to help remind us in the calculator it's necessary in that step. We'll go 1 minus 1 plus APR over 12. And here's where that other question came into. This is the spot where the negative exponent comes into play. This is raised to the power of negative, it's n in the formula, but we swap in a 12 times the term length. So there's our entire formula. Next step, we need to evaluate it. So let's plug in our values. Payment is going to be, first take that huge chunk of money, 375, 500. We're multiplying this against 0.0549 divided by 12. Then very carefully go 1 minus 1 plus 0.0549 divide by 12 again. And a pretty helpful step to take in our calculator is, let's just take negative 12 times 30 right here, so we don't have a needless multiplication that's quick to resolve. The exponent is going to be negative 360 altogether. So that's kind of an interesting round number. Negative 360 goes up here in the exponent position. Negative 360 for the exponent. So putting all of that together, and again, going very, very carefully in the calculator, we'll see what we get. Let me know if you're getting anything different. And just one more reminder on an exam, if you're very, very confident and you put nothing but the payment amount, I would accept that for full credit if you have an accurate answer. If it's off by, say, a relative error of 5% or more, you could start to lose a lot of credit on the question. And so anything you put down here on paper is a massive amount of partial credit. So if this is 5 points, I would consider just to this step 4 points out of 5. I don't want to overemphasize the calculator itself for credit on the exam, is the thought. So let's try to go for that last point, 375, 500. 0.0549 twelfths divide by 1 minus, let me put in the parentheses just to emphasize, don't forget those either. 1 minus 1 plus 0.0549 0.49 to the power of negative 360. So it's a mortgage payment. So if you see a pretty scary number like I'm looking at, that's not too bad. That's in the right ballpark for this kind of scenario. Their payment is $2,129.69 rounded to the nearest penny. Well, we've got our value out. Any questions at all, folks, getting the payment? Okay, with that payment down on paper, now we can turn over to see just how much they're going to pay over the entire term of the loan. It really just came down to that number times 12 times the term 30. The logic behind that, it's 2129.69 per month. But then we can now do a unit change here and say that there's 12 months per year. Then we want just a dollar amount, so we have to cancel years. We're multiplying by 30 years altogether. So the units cancel out, months are gone, years are gone, and we're just getting the dollar sign unit. So let's see what this comes out as next. Altogether, they're going to pay looks like just above $750,000, 766,688 and 40 cents. Let me double check those numbers again. 766, 688 and 40 cents. It's kind of interesting. It came to a nice round cent there. So their original principal was about 400,000. They're paying over $750,000 altogether. So this analysis isn't going to look too pretty, but it's usually how these kind of things go for a 30-year mortgage. Picture gets worse and worse the higher that APR goes. So we want to know what percent paid was toward the principal. What percent paid is just for interest purely. So this is the typical step we wrote out on this stage. Percent paid to principal. You don't have to write down that whole statement, but indicate some way, somehow, which number is the principal, which number is the interest for full credit. This is going to be take the total payment in Part B, 766,688, 40 cents. That's dividing into the principal, 375,500. We want a percent here, so go times 100%. And here's our next computation. 375. Oh, that was not what I wanted to do. Let me try to fix that. There we go. That's the F11 button if you're curious. 375,500 divide by 766,688.40 times 100. You know, it's not that bad. It's just not a hugely pretty picture. It says rounded to the nearest percent, or as some people did in quizzes, let's round to 2 decimal places, 48.98%. Which means more than half of this money right here over the course of 3 years monthly, more than half of that in sum total went to nothing but interest. And even though the interest rate seemed kind of low, the principal's high, the term is really, really long. And so this is what finalizes the last step on this one. Percent paid to interest We can do a similar equation like we did right here, but that would take a little more steps altogether, I would say. So it's a little bit easier to instead go 100%. I think this is how we did it every single time in the notes, minus the portion we just computed, 48.98%. So 100 minus 48.98 gives us a 51.02%. So a little more than half just vanished to interest. Yeah, on this one, I never said what to round to. I said here, don't round to the final answer. When we did this one in the lecture notes, we were rounding to 1 decimal place. And I think the homework did the same. But for what this is saying, if I don't say anything about rounding, you rounded to 49%, I would say that's very, very reasonable. I'll try to make sure I include those instructions, but 49% would absolutely be a terrific answer as well, especially if I say what to round to. Sorry for that omission. Other questions or comments on this one? Looks like I forgot the percent symbol as well on that. I wouldn't be too worried about forgetting the percent symbol. Okay, again, these questions have a way of being really tricky, but the more details you show, the more you dig out of the context, show what these values are, show how it comes together, they won't be too bad. If you made the smallest, simplest calculator mistake, this number can be wildly off. It's kind of unfortunate. But if you use that same number in part B, you're not going to lose credit if you use that number correctly, whatever it was. And if you're using those numbers from parts B to do these down below, and you're using that number, even if it's wrong, use that number correctly and I'll accept what those percentages are. So in other words, you're not going to get double, triple, quadruple jeopardy if you make a mistake earlier on. I'll track through the results with you. If you had this as 28 years for some weird reason on accident, but everything else is correct, you might have lost just 1 point, something like that. Yep, you bet. Thanks for asking about that one. Well, there's definitely a lot of different kind of questions that we still haven't hit on. And one section we haven't taken a look at yet is this kind of stuff. The consumer price index table. These kind of questions have a way of being really pretty tricky. And so 2 questions I think you should be ready to go with are something like a question like 32 or a question like 34. These are kind of similar. You definitely want to be ready to go for a question like 33. I think this one has a way of being extra tricky. There's a formula that goes along with it. So let's maybe do 33 just to make sure we cover our bases on that. That's kind of a hint on the exam. You should definitely expect something like this on the real exam too. This one involves a formula, and that formula is not provided on the exam 2 formula sheet. This was mainly just absolute relative error and a couple financial formulas. So as we go to take a look at this one thing I'm going to print on the exam for these questions is the CPI table will just be there. So please don't feel like you have to copy any of this down on your notes for the exam. Let's throw that into the problem as well. But to solve a problem like this one reliably, without taking too much time, kind of reverse engineering how we think it should go, here's the next thing I would dig out. This is a formula I definitely would recommend including on your exam 2 notes. This is, I believe, unit 3D we're going into. And it is going to be this formula. Where'd it go? Right here, adjusting prices for inflation. Or was it that formula? Hang on, let me take a look. You know, it wasn't exactly a formula. I think that's where I'm getting mixed up on. It was really just a short definition, which implies a formula. This is how we worked it through. So let's take this definition And then we'll write our own formula to match the problem, which is kind of what we were doing down below here. So to work through this problem, here's the concept that we're going to need as well. The rate of inflation from one year to the next is the relative change in consumer price index. And now you will have on your page of notes on the exam, sorry, wrong screen there, you would have relative error. The relative change is the same kind of idea, but just a different context. We're not talking about error any longer, but same sort of structure. So as we go to look into this problem, it's asking, what was the overall increase in prices due to inflation as a percentage from the year 1985 to 2000? We're assuming all prices have risen at the same rate as the CPI. And so this rate of inflation can be inferred through the CPI table, Consumer Price Index. So here's what we can do to write down this. Rate of inflation from the base year of 1985 to the target year, year 2000, is going to be using the CPI index table. We'll take the base year, the consumer price index at 1985, minus the consumer price index for the target year, that's year 2000, divide by the consumer price index. Hang on, let me think about this. I think I got this one flipped around. I think I want the CPI for 2000 to come first. Let me double check how I did on this, the notes. Hang on, this is sample exam, getting a little bit mixed up with all my documents. Doing this in the notes, we're looking for, here we are. Yeah, I think I got my years backwards. The value I'm going to get, the reason I stopped is I'm going to get a negative value. And that wouldn't be necessarily incorrect, but the negative sign implies a direction of inflation going down, but it's in fact going up. So we should have the base year on the right, not on the left as I did there. So let's fix this around. 1985 should go here. 2000 should go here. And 1985 should be the denominator. So that's the basic structure. But then at this stage, all we're doing is throwing in those index numbers. So go to consumer price index in the year 2000, 172.2. Subtract from it. And again, you'll know something is off if you're getting a negative. Inflation should be going up in this direction, 1985 to 2000. Then here, for 1985, we had consumer price index of 107.6. Then divide by 107.6 times 100. With a percent symbol for the rate of inflation. And then finally, this is how it all comes together. We're just going to dive into the calculator on this last step and take 172.2 minus 107.6. The base year must go into the denominator, so that's consumer price index of 107.6 again. Multiply that by 100, and we round this to one decimal place, we get 60.0%. So the rate of inflation from the year of 1985 all the way over to year 2000 was 60%. So goods across the board increased by approximately that value, whether we're talking about housing, cars, the price of milk and eggs, and so on. So again, that's a kind of a random and easy question to get mixed up on. I got my years mixed up on that numerator. So watch out for this one. This is just a major hint for the exam on this kind of concept will be asked. Aside from that, other concepts could be asked with their CPI index table as well. So let's take a look into another one as well. But first, any questions or comments on getting through this one?
Yes. You got 60% on that? Because when I did it, I got 72.2%.
Let me double check my numbers again. Let me wipe this out. Sometimes it's better to just start fresh. So I have a 172.2 minus 107.6. Down below 107.6. Then times 100. So yeah, it looks like I'm getting
I think I skipped
60%.
this. I think I skipped a step. That's totally on me.
No worries. The step that I usually do is sometimes I go like this, 106.7, just transpose a couple digits, and then I'm off by either a little or a lot, depending on the problem. But other questions at the moment?
I think I got the same answer, and that was because in my calculator, instead of subtracting the 172.2 from the 107.6, I just did it all together at once, and then it gave me the same.
Yeah.
Yeah. So instead, when I just subtracted it first and then did the division and then the multiplication,
Oh, gotcha.
I got this. Yes. I don't know why my calculator has been doing that, but I've been having troubles with the APR too because of all the calculations, and it's just screwing me up.
Well,
Got
when I
it.
do the APR stuff, I do it exactly like that. I just put it in like in that big line like we talked about when we were doing the chapter.
Mhm.
And I always get the right answer doing that, but doing it this way, it seems weird that we would like not do it in a line like that.
Yeah, I have the same issue. You have to like do each separate calculation to get the correct answer.
You know, one thing that could be going on is if we type it in like this, say 172.2 minus 107.6, then divide by 107.6, the calculator could be interpreting something like this, giving a funny value. But if you instead put the entire numerator into parentheses, 172.2 minus 107.6, and then in that step go division by, if it'll let me, division by 107.6, then it should come out right there. So it could be just to the parentheses being missing, causing the error.
That is it.
Gotcha. So yeah, so on this one, putting into the calculator, let's make this a concept on the, write this concept down. Make sure it goes in as 172.2 minus 107.6, then division by 107.6. And then that should work out for that value. Well, other questions or comments with that computation there? Okay, and you know, I did hear that another comment made that this one has in fact been pretty tricky. So let's maybe take another look into this one and see how this one can go if we're working it through a calculator as well. So putting something like this one into whichever kind of calculator we're working on. The reason it feels different from this problem down to this one is all because of that negative sign in the middle. It's kind of interesting. With the negative sign in the middle, you really have to wrap the entire numerator around with parentheses. But if it's just a multiplication like this one, whether you put a parentheses around it or not actually didn't matter in the calculator. So we probably got used to just not putting parentheses around this at all. But the bracket here was like a really big red flag telling us because of the minus there, separating out this group and the one, we really needed that parenthesis. And I thought it was weird the author printed that until I thought of, no, that's just kind of insurance that we don't miss that step in the calculator. So watch out for the negatives, whether they are in the numerator or a denominator. Probably best on paper, just for the emphasis, for us to write these out this way, just so that we don't get a miscomputation right on to the next step. But again, if this is on paper on the exam, and we make a calculator mistake, we get essentially all the credit right at this step. But this one in the calculator would look like this. You can put parentheses around the numerator, but it's not necessary. So we often just put in 375, 500 times 0.0549 divided by 12. We closed a parenthesis there. Then for the division bar, we hit division again. Then we opened another parenthesis for here, went 1 minus, new parenthesis, 1 plus 0.0549 over 12. Then here, we hit the exponent button. And most calculators, you can be okay by hitting the negative sign, not the minus key. So it looks like it's a little bit higher than the minus key, oftentimes a little bit shorter, 360, then close 2 set of parentheses for the 2 open ones from over here. So it's kind of nasty looking in the calculator. It comes out like this. And then we should get the right payment after running that through.
Every time every time I do that, it says syntax and then it says error. That's been happening
Gotcha.
every single time for me, and I'm not sure why. I'm not very good with calculators either, so.
Well, what kind of calculator are you using for this one?
I'm using the TI-30X IIS.
Gotcha.
You have
So
to,
that was a
I-
pretty good
Doing
one.
Did
the
that
same
one?
thing for me.
yeah, and that one though, you absolutely have to do the exponent, like the months times the months where you have the negative months up there, that has to be done separately before you start the problem. And then you have to make sure your parentheses are in there correctly for it to come out right.
Yeah, let's run through it in. I don't have a great way to show the TI-30X2S on screen, but I'm going to we've done this once before. Let's do this again. I'm going to use a band calculator only because the readout is similar to your calculator. The TI-30X2S has a screen that looks about like this one. I think we did the TI-83 before, but I think the TI-84 is even more similar. So if we're putting this into the TI-84, let me just double check. No, it does do the exponent differently. Let's switch this around. We'll do that TI-83. So let's give this a try again on the, again, TI-30X2S, because that's the one allowed on the exam setting. But this is going to give us a good readout because the keys are very similar and the screen is as well, to about what this should look like. So let's key this in really carefully. Again, I'm glad you asked about that one. Sometimes that's the trickiest thing on the exam. And it's worth a point. Every point matters. So let's give this a try. 375, 500. Then moving left to right, next thing we hit is the times key. We'll use these keys here for parentheses. And, I do have a calculator just for reference. Let me open that one up. I have a calculator somewhere. Let me see. There it is. So here's the reference calculator to the right. So get this screen to behave correctly. There it is. Here's the calculator we're going to do just because it'll work actually. So you'll have the same parentheses you're going to work, just like these parentheses here on these keys. Then 0.0549 divide 12. This calculator just keeps going on to the right, but here it drops down to a new line. Here's the closed parenthesis. Here's the division, and it takes us to this stage. Then open a parenthesis and go 1 minus, open a new parenthesis, and go 1 plus. And Amy says also don't put 2 on the end, just the 1. Oh, I think you're referring to this part right here, potentially. That these wouldn't combine to a two, we'd have to put in just
No,
a.
I'm talking about at the very end, if you move to the end of that row where you were down here. Yep,
Yeah.
all keep going. It after the negative 360 parentheses, you're ending. The first one is actually ending the big brackets. So you
Oh,
don't
I
need
see,
that
two
second one.
parentheses, yeah. Good call, yeah, so one parenthesis for this one. Hang on, let me look at these parentheses. This parenthesis, yeah, goes with this one.
Yeah, see,
You
you've
know,
got two at the end. I don't know why you have the second one because you don't need that second one. The first one is closing out the one that's before the one minus.
yeah, so this one is extraneous.
There
That
you
one's
go.
gonna cause an error for sure. Yeah, thanks for spotting that. Good eye on that one. So usually the way you think about this is we've opened two, just like you were saying. So it should only be two closed, not three altogether. Thanks for mentioning that. So now we've got the one minus, the one plus, and definitely gonna close two. Let's go inside here, 0.0549. Divide by 12. Here's where it starts to get a little sketchy. Close the first parenthesis. Then hit the exponent key. On the calculator to the right, the exponent key is going to be this one. But I find the next trickiest step is even beyond that. Oftentimes the syntax error is pointing towards that right there. These calculators are extremely particular. When you go in to put a negative, it has to be that key specifically. So that negative sign right there is the most dangerous spot, in my opinion, aside from the parentheses, obviously. After the parentheses, that's the next sketchiest spot. So hit the exponent, you'll see the up arrow. Then type with this key, analogously, it has to be that key there, negative 360. Close that last parenthesis, and we should be getting that figure there. So let's hit enter and hope for the best. So I got it to come out to what we were expecting, but how did it go on your end? Did it throw a syntax error at any step?
Yeah, I did the whole thing again and it gave me an error again, and I'm not completely sure why.
It's kind of strange. Yeah, it sometimes can be really frustrating on these calculators, but you know what you can do as well is hit the up arrow. That's going to recall the last computation. And kind of annoying, but if you could take say, a cell phone picture of your line from start to finish, send it to my email and I can take a look at to what could be causing that error. What part of the input is causing the weird anomalous syntax error at the very end. Lots of things can go wrong on this one. So if I were to go and change anything to like, say once again, this is the mistake that I usually catch a lot, but it sounds like it's something else on your end. If I had a negative like that, then it would say syntax error, kind of like what you're saying. So you should be able to go to the go-to statement. I forget exactly what it looks like on this calculator. And then send me a picture of what that output looks like. And I'll be happy to work with that with you on email, try to isolate where the error might be coming from. But again, on the
Okay.
exam,
Thank you.
yep, you bet. Make sure you've got this down on the exam, just what's about to go into the calculator, and that'll be a ton of partial credit because again, these can be really frustrating, especially when there's so much stuff going together. And especially because this calculator, it just gets worse on this one. I didn't know how to do this at all in this calculator. I separated it as top versus bottom, numerator versus denominator. Then I had to learn from suggestions in the class that you can actually put it in one line like this in even that calculator, but it's a lot real trickier to get that done, although possible. Well, we're just about out of time, but 5 minutes could be one entire question. Any questions folks would like to take a look into for our last amount of time? Okay, maybe one last piece of advice for one area that we didn't get quite to, but still important, still is going to be on the exam is watch out for these kind of problems. When it comes to significant digits, they have a way of being particularly tricky. And especially if you combine them with operations. So let's maybe do, how about one last question? We're going to look for number of significant digits. And we don't have time for every single one. So let's try for maybe part D. So here's the question. And one thing that's not provided on the exam would be these notes right here. Back to chapter 3 on putting numbers in perspective. No, it's not that one. Let me try again. Dealing with uncertainty is the right section. This would be a good set of information to put on your exam as well. So this is kind of like a nice just summary of what we mean in the first place when we say significant digits. So let's convey its importance by just throwing it into the notes. How about down below? Now let's work out part D. Now part D is tricky because of this portion right here. We're doing a division problem, and we're also working with exponential notation together with scientific notation all at once. So first thing you can do is just separate out this problem. Let's do the 4.56 divided by the 1.23 and get a number there for that portion. So for that portion there, let's go 4.56 divided by 1.23. Here's the big number we're getting, but we're going to have to put this in scientific notation as well. So I'm not too sure how many digits. We're also going to go for 3 significant digits, so some rounding will happen. So let's carry a lot of digits. 3.707, 317. So that's the integer or the decimal parts divided against each other. Now for the next part, let's work this out carefully on paper. It'll be 10 power negative 2 rather. Let me start over. 10 power negative 2 divided by 10 power negative 5. That's a tricky problem with exponent laws, but you can force both of these positive by taking the negative one in the numerator, throw it down to the denominator, now its exponent's positive. This one, which is negative, you can throw it up into the numerator. Now it's positive as well. And then we just subtract the exponents. There'll be 5 minus 2 for 10 power 3. It works here as well, but it's negative 2 minus negative 5, so you have double negation, a little bit trickier, getting you the same value. But a whole nother take on this is you're allowed to have a calculator, and there's no restrictions on how you use it. You can interpret this problem as 10 power negative 2 divided by 10 power negative 5 gives you 1,000, and so that's why we have 10 power 3. So putting it all together, it's 3.707317 times 10 power 3. It's already in scientific notation, so that's great. We don't have to decimal shift anything. But we also want 3 significant digits. Now, there's different ways to interpret this. I'm usually interpreting this, and I think this is what my lab did as well, what we did on the homework problems. We're interpreting this as round to 3 significant digits. That means this would round up to 3.71 times 10 power 3. But if you interpret this as keep 3 significant digits and you gave me 3.70, I would say that's an acceptable answer as well. That's just a different interpretation of what these instructions were saying. They didn't say specifically to round to, so either version would be acceptable. But by 3 significant digits, it would mean these 3 digits right here. Well, that's our last problem for the review. For all these problems, I do have the full set of solutions on the sample exam, wherever that sample exam went. I think I lost that one. Well, for his sample exam version 2, where we grabbed a majority of these examples, wherever that one went. Oh, here it is. There are solutions at the very bottom, but if you see anything wrong, it's probably my mistake. Let me know right away. and I'll get these revised as soon as possible. For version 1, the solutions are just on Canvas because they were the ordinary lecture notes. And if you have any questions whatsoever that might come up, whether it's a calculator issue or otherwise, don't hesitate to reach out, send an email, and I'll be very happy to help out. But any last questions or thoughts, folks, before we call it a night? Okay, well, have a great weekend, folks. We'll be back to it on Wednesday. We won't hold class on Monday due to the exam, but take care. Have a great weekend.